Hey everyone, welcome back. It's Mr. Anderson, and today we're going to talk about section 9.3.2 from our CP/M Common Core Algebra text. And we're going to start to look at some inequalities that aren't linear. So we're going to have some familiar functions that now we're going to look at through the lens of an inequality. And this comes from 9.3.2, and I'm going to tackle a couple problems taken from this part of our text, okay? As always, we've got some modified notes here. And we're going to start very, very quickly with a review. Now, I took this problem 9-77, and we are going to graph this inequality. And as we do this, let's recall that this item right here, the scalar multiple in front of the x, this happens to be our slope in slope-intercept form. And this, of course, happens to be the y-intercept. And don't forget those signs in front of those numbers because those do matter. Okay, so real quick, we're going to go ahead, we're going to get that thing graphed. I recognize that it is a greater than or equal to sign. That does mean I'm going to need a solid line. So it is y is greater than or equal to negative 5/3 x minus 3. So I'll start right here at the negative 3, and then I will simply go down 1, 2, 3. Oh no, I can't go down 5. Don't forget, you can go up 5. 1, 2, 3, 4, 5, and in this case to the what's it called? The left 3, right? There we go. I've got a name. Let me just verify that I did this correctly. 1, 2, 3, 4. Yep, I did. Okay, and that way I still have that negative slope, right? And that was just because if I tried to go down 5, I'd be going off my graph, and I can continue to do that again. I can go up 5 and back 3, and there's my line, and it is going to be a solid line, so I will do that right there. Put some arrows on the end. Okay, now, if this was an equation, we'd be done. But it's not an equation, it's an inequality. So as we discussed, right, let's test a point. And specifically the point that I encourage you guys to test because it makes the math easy is the point 0, 0. So if I plug in a 0 for this and a 0 for this, we're asking the question, right? We're testing, is 0 greater than or equal to negative 5/3 times 0 minus 3. Now, the negative 5/3 times 0, that makes this whole thing cancel out. Okay, so really what we want to know is 0 greater than or equal to negative 3? And that's a true inequality. That is 100% true. So this right here is a solution to my inequality. And what we discussed in our last video is that means every single point on this side of our boundary would be a solution. So we could spend a lot of time making some dots over here. Problem is we'd never make all of the dots, so we just shade. Okay, if I was going to go ahead and test any point over here, right, let's say I decided to test this right here, this would give me a false inequality, so we're not going to shade anything on that side of the line, right? They ask in this problem, you know, why is 0, 0 a convenient point? And as I already mentioned, this really makes the math easy, right? Plugging in 0 for x, plugging in 0 for y, it makes our math so nice, okay? They do bring up maybe something something semi-interesting here. They ask, hey, Anita, decided to use the point negative 3, 2 to test the inequality. Well, you can see that I've already got that point right there. And then it says, does this help her decide which way to shade? And unfortunately, no, that doesn't here. Because that's a point on my line. And if you pick a point on the line, it's kind of like, it's going to tell you whether all the points on the line are true or not true. But we already know that based on what type of inequality symbol we have. Okay? So if you want to use 0, 0, that's fine, but don't use 0, 0 if it's on the line, right? You're going to have to use like 1, 1, and hopefully that's not on the line, right? Pick a point that's easy to do the math with. I generally recommend if 0, 0 doesn't work, you know, maybe you pick a point in the first quadrant over here because that way, you know, we've got some pretty nice and easy math, okay? Let's keep on keeping on, and let's look at our first inequality that isn't linear. So check this thing out, right? What if we've got a nonlinear inequality? Well, I've got something right here that is a parabola, right? Decide with your team how to graph. Well, obviously we don't have a team here. It's just you who are watching the video, me who's making the video. And we can use some graphing shortcuts to give us some help here, right? And what I'm going to do real quick is I'll remind you guys of something you may have seen before, that we have this idea of the axis of symmetry when it comes to a parabola. And the only thing that I need to do is identify what a and b are, right? A is the number in front of the x, x squared, b is the number in front of the x. Okay, and we have this axis of symmetry that is negative, sorry folks, negative b over 2a. And if I work with this, negative b is negative negative 4. Okay, 2 times a is 2 times 1. And I'll just do a little math. That's positive 4. That's 2. My axis of symmetry is going to be 2. Now, what does that mean? Well, a couple things. That means I've got a imaginary line right here. And I'm going to get rid of this imaginary line in just a second here. But I'm just dashing it in because it truly is imaginary. And that's that line that we've discussed multiple times that runs up and down the middle of my parabola, where if I folded my parabola, I would go ahead and I'd have two halves that folded onto each other and match exactly, right? It's the line that defines the symmetry of my shape, my parabola here. Now, the other reason I care about my axis of symmetry is because you see what I have here. I have a table. An axis of symmetry is a really nice thing to symmetrically cut your graph in half, but it also symmetrically cuts your table in half. So I'm going to put that axis of symmetry where I know it is right in the middle. And then I'm just going to work one way in either direction. So I'll go right there, right, count by ones, and I'll do this and count by ones, okay? All right, so now I've really got my table defined, and now I can quickly use, I'm just going to open it up here, my calculator to do some evaluating and get some y's. So, for example, I can plug in 0. Well, golly gee, plugging in 0 gets those x's to disappear. That gets this thing to go away, it gets this thing to go away, and the only thing I'm left with is a 3. So when I plug in 0, I get out 3. Now, again, I'm going to use this idea that I've got this symmetry. If y is 3 right there, y is going to have to be 3 right here, right? Those are some of these graphing shortcuts that we have available to us, okay? Let's plug in 1 and see what happens. The x's don't drop out when I plug in 1, but when I plug in 1 and do some evaluating, let's see, 1 squared minus 4 times 1. Oh, you know what, folks? I'm sorry, I missed the negative, right? Those are negative 3's. Sorry about that, okay? Don't want to forget that, right? It matters, okay? If I plug in 1, it's going to be 1 squared minus 4 times 1, which is minus 4, and then minus 3. This works out to be negative 6. Likewise, this is going to be negative 6. Now, maybe the hardest part, I got to plug in 2. And when I do plug in 2, let me show you exactly what I'm doing here. I'm going to go ahead and I'm just going to plug in 2 for x. And I'm going to work this out. This turns into a 4. This is 8, right? And then I've got 4 minus 8 minus 3. This does work out to be negative 7. Okay, so now I've got 1, 2, 3, 4, 5 points that are graphable. I'm just going to transform over here quickly to my graph. And I start to see that nice looking parabola take some shape there. And as I mentioned, I am going to get rid of this because I do want to be able to graph this line and test a point. Okay, so now check this out. I've got a less than scenario. So I'm going to try my darndest here to make this parabola. And if you need more points, you can go ahead and graph more points here. But check it out. I'm graphing this with a dashed line. I've got the general shape of my parabola, which for our purposes, right, because graphing is typically for estimation, right, this is going to be good enough. And I notice that there's a point that I can test, anywhere, right? I could test 0, 0. I don't want to test anything on my my graph, but maybe I made a little bit of a, you know what? I know it's not going to be too tight there, so I definitely can test 0, 0. Let's go ahead and do that. 0 is going to work out nicely here. And I'm questioning, is 0 less than 0 squared minus 4 times 0 minus 3. 0 is less than 0 squared, right? That drops out. This drops out. Is that less than negative 3? And the answer is no, it is not. So this is a false. This is a false right here. It is not a solution. And what that means for me is I have to then shade everywhere on the other side of my boundary. And I can go ahead and do so like this. Okay? And so we still test, we still shade. The process is the same, even though the graph looks different. Okay? So that's what we can tackle when our situation is not a linear one. Okay? Let's go ahead and look at one more. And one more time, I'm going to use a table to help me with the graphing here. All right? I've got a situation here where I can start at 0 one more time because I've got a table, right? I really could start at a lot of different places, but we know kind of how these exponentials behave. But what I'm going to do real fast is I'm going to remind you of the opportunity to use something like Desmos for this one, right? Okay, and you guys all have access to Desmos. It is a free open source graphing calculator. It's available at desmos.com. And we just are going to go ahead and I'm just going to graph the equation, right? You could definitely graph the inequality to see what it looks like, but I don't want to give anything away quite yet. All right. I'm just going to graph the equation and there we go. And what I'm able to do here is I'm able to have this make the table for me. Now, I don't know if this is something that you want to do. You certainly could, but I can just copy this table and I'm going to do so onto our notes here. And some people have questions about rounding, like, gosh, what do I round to? And I would say like, oh, I don't know. How about the nearest tenth? I think that's going to work out pretty gosh darn well. So that would be like 3.0 and then like 3.5, right? Because remember, graphing is for estimation. And do you really think you can estimate any nearer than the nearest tenth on a graph when you're making one? I'm not sure I could. So that's why I tell kids, like, use the nearest tenth. And now transfer these things effectively to our graph. Let's see, -1, 3.5. Okay, and then 4, 0. And then 1, 4.6. And then 2, 5.3-ish, right? And the other thing that I see here is I see that little ramp style shape of the exponential function, and I'm going to want to try to make that this way. And as I'm doing it, recall that this is a less than scenario. So I am making a dashed line, okay? And there we go. Now we've got a graph that's on here, and it's an inequality, so let's do some testing, right? You guys know this by now, I do like the 0.00. Let's test it. And that just means, hey, plug in 0 for y and for x, okay? 1.15 to the 0 is just 1. And then 4 times 1 is 4. So is it the case, or is it true that 0 is less than 4? And the answer is, it sure is. All right, so what I can do is I can just make it clear that this is true in indicating that this is a solution, and I'll try my best to use that as a boundary and shade without crossing over that line. And there you go. You've now tackled an exponential inequality. All right, ladies and gentlemen, just a little bit of review preview after the problem there. Not a ton, just designed to get you, trying things, asking questions, and maybe kind of fleshing out what kinds of questions you have. Ladies and gentlemen, I appreciate you watching. Have a great day.